Hello everyone. Today we have a question from how to calculate the damp natural frequency WD of a vibrating system. Now let's read through the question given to us. A vibrating system consists of a weight of 176.9642 Newton and a spring stiffness of 126.2435 Newton per meter. Is viscously damp such that the ratio of two consecutive amplitude is 15.14569. Calculate the closest value of damp natural frequency WD in radian per second. Once again, a vibrating system consists of a weight of 176.9642 Newton and a spring stiffness of 126.2435 Newton per meter. Is viscously damp such that the ratio of the two consecutive amplitude is 15.1496. Calculate the closest value of damp natural frequency WD in radian per second. Now, let's assume this particular system can be represented with the schematic given here today, where a weight is being suspended on a viscous damp downward, and the weight is acting downward with a gravity of 9.18 meter per second squared, whereby the response of the sinusoidal effect of the vibration can be represented here, whereby we have the ratio of the two consecutive amplitude x1, x2. Now, by putting out our parameters, we have our weight 176.9642 Newton given, the case constant for the which is the spring stiffness is given 126.2435 Newton per meter, and the ratio of the consecutive amplitude 15.145 is given. Now, by deducing that W equals mg, and by using the equation to find the mass, which is m equals W over g, that gives us our mass to be 18.04 kilogram. Now that we have mass of the body suspended on the spring and a damper, we can deduce that our Wn will equals k over m, becomes this value, which is Wn equals 2.65 radian per second. Now, to find the damping ratio, which is zeta, by using this particular formula, zeta equals the logarithm ratio of the consecutive amplitude, which is zeta, over 4 pi squared plus zeta. So that becomes 2.72 over 4 multiplied by 3.14 squared plus 2.72. And don't let us forget to find the the natural logarithm of the two consecutive ratio of the amplitude, which that give us 15 point natural logarithm of 15.1459, that give us 2.72. So by using the value, we can find our zeta, which is the damping ratio, which equals 0.4. Now that we have the damping ratio, we can use the formula of WD equals Wn into square root of 1 minus zeta squared. So that gives us 2.65 square root of 1 minus 0.4 square. That gives us 2.43 radian per second. So the damp natural frequency of the system here today becomes 2.43 radian per second. Thank you.